Okay, let's graph some logs and exponentials. So we're going to start with an exponential equation because that's actually pretty easy to graph, and that's what you need in order to easily graph a log. So let's start with this very basic 2 to the x minus 1 plus 2. So the exponential function we're looking at is base 2. So as normal, we're never going to make a table with all these shifts in there because that just gets way complicated. As we always do, we're going to make a xy table of the parent function. So the parent function is actually 2 to the x. So xy, and remember y is 2 to the x, and I'll go ahead and put all the numbers down, -2, -1, 0, 1, 2, and please, 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 please don't forget negative numbers. I had a couple of students on the last assessment that did not put negative numbers, and so did not have a complete graph, and sadly I had to take credit off. So we're going to plug in those numbers, 2 to the -1, 2 to the 0, 2 to the 1, 2 to the 2, and then we're going to see what those equal. So 2 to the -1 is actually 2 to the -2 is actually 1 over 2 to the 2, which is 1/4. This is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 to the 2 is 4. Now we're going to plot these on this graph. I'm going to plot them in yellow because we're going to be shifting, and I want that to be a different, better color. So let's go. -2 over 2 up 1/4, little dot there. -1 up 1/2. Oh, there's my locator point. Woo! Which locator points, I don't know if you've noticed, but they really don't help you that much during exponentials. It's such a lie. All right, so over 1 up 2, and then over 2 up 1, 2, 3, 4. Oh, look at this beautiful exponential. Now, what you always want to remember and never, ever forget is that this exponential will never, ever, 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 ever touch 0. So if you're like, hey, what exponent makes 0? That is nothing. You can't get there unless you're a shifted function, but we're not. So we're going to write the regular exponential function, and remember it gets closer and closer to 0, but never gets there. So now we're going to actually shift it, and this is what I'm going to use my lovely blue, and we're going to take every point. So this is transformation form, so we're actually moving it to the right 1 and up 2. So every single point is going to the right 1 and up 2. So this point was just shifted, if you notice, over and up to the right 1, up 2. So this point has actually been shifted to this point. And we can do that because the shape of the graph doesn't change at all. Only thing changes is where it is. We just literally picked up this graph and moved it. Ooh, I bet I can do that with this iPad. Maybe we'll try in a minute. Or let's try this one, over 1, and then up 2. 1/2, that's fine. 1/4, over 1, up 2. Isn't that beautiful? Now, the first thing I probably should have done, since it's a +2, I didn't, but I'll do it now, is that asymptote was at x equals 0 for this function, right? There it was here. Now I'm going to move the asymptote up 2. So everything gets moved up 2. And it's really important you draw that asymptote because then when you're drawing your graph, it makes it super easy just to whoosh, kind of go along the asymptote and go up. And that's how you graph an exponential. All right, let's go graph a log. Let's go graph a log. All right, so now we're going to graph log of base 2. Woohoo! It's the same base. So I can just use my table. So my table from before for 2 to the x. All right, remember that? It was -2, -1, 0. I don't know why it's not writing. 1, 2. Let me try that again. And then my y coordinates were 1/4, 1/2, 1. 2 to the 1 is 2. 2 to the 2 is 4. And that is the table for y equals 2 to the x. But I want y equals log base 2 to the x. And remember, when you know a function, to graph its inverse, you literally just switch x and y. Because in our equations, also we switch x and y as solve for y. So we can totally do that. So we're switching y with x, right? But that becomes our new xy. So let's not put that there because that looks crazy. All right. Let me erase. There we go. All right. So Here we go. So now our new x, y are just these points reversed. So I'm going to do a different color. So we've got 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. All right, so those are the points I'm going to graph now. So I'm going to graph those in light green so that I can shift it later in blue. So over 1/4 is x, down -2, that's right there. Over 1/2, down -1. I'm going to go to 1, 0. Oh, that was bad. Let's try it again. 1, 0, 2, 1, and then 4, 2. Woohoo! Now, important, don't forget, since our asymptote was x equals 0 for this one, I'm sorry, y equals 0. Did I say that before? Oh, I'm so sorry. Our asymptote was y equals 0 for this one. On this one, it's actually x equals 0 as our asymptote. So now, the x equals 0 is our asymptote. So we will not touch it. And here's our parent function. So I'm not really good at drawing these, so I'm going to start from the middle and get closer and closer, but never, ever, ever touch that asymptote with a log function. Now I get to shift. When I shift, you shift, we shift. All right, so x minus 5 means we're going, remember transformation form is x minus, h. So this was before x minus -5. Don't know why this thing is starting to get mad at me and not writing, but you get it. So we're moving -5. So we're moving -5 or left 5, and then again up 4. So every single point, so this point goes 1, 2, 3, 4, 5. Oh, and then up 4. 1, 2, 3, 4. Again, what I should have done first, did not do it so bad, is this asymptote, I want to take it over 5. That'll give me a guide. 1, 2, so it's at 0 right now. 1, 2, 3, 4, 5. Here is my new asymptote. Okay, awesome. So that'll give me a guide of where I want to go. So I did that point. Now I'm going to do this point. 1, 2, 3, 4, 5. Up 4. 1, 2, 3, 4. Oh, looking good. And this point is 1, 2, 3, 4, 5. Up 1, 2, 3, 4. And now look, I've got all this graph over here. Look at all this graph I have, right? So I'm actually going to go one more point that I did not do before. I know that 2 cubed equals 8. So that means in this table, I'm going to have 8 over here, out of room, and that gives me 3. So I'm going to go over to 8 and go up 1, 2, 3, which means my sketch wasn't as great as I'd wanted to. But that does then allow me to, from this point, go 1, 2, 3, 4, 5, up to 3, and it makes it a little more accurate. Did I count bad a minute ago? Let's see. 1, 2, 3, 4, 5. I'm sorry, up 1, 2, 3, 4. I knew something was wrong. There we go. All right, this is beautiful. Now let's go to our little fractional parts. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now there's actually an even easier way to graph these, and that's with transforming each ordered pair. We haven't really talked about that, but I'd love to show you guys that maybe later. And actually, if you want to see it, I could show you now. But if you're good and you're like, I know how to do this now, you can stop the video. But if you want to learn some more, I'm going to erase this part over here, and then I'm actually going to show you something else, if you would like to see it, because it's pretty cool. Erase all this, and it makes it super easy. You don't have to count and stuff then. It's like just super nice. All right. So this is something I'll be teaching you soon. So hey, if you're interested, why not learn it now? And then here's what it is. Basically, and let me erase all this, it's such a mess. Okay, basically, we are taking log base 2 of x, and we're transforming it to log base 2 x plus 5 plus 4. So this means every x coordinate is being moved to the left 5 or -5. Oops, -5. I was thinking about x's. So the x is moved -5. So it's like x is moved -5. So every x coordinate, like this 1, we subtracted 5. 1, 2, 3, 4, 5, and we arrived at -4. and every y is being moved up 4. That's what's happening to every single point on our table. So if we have our original table, which we do, x, y, our original table was, let's just do a couple points, we don't do all of them, but 1, 0, 2, 1, 4, 2, right, let's just do a couple. So in order to transform these new points, each point, this is what's going to happen to every point. This is the transformation. So I'm going to highlight this so you guys can see this really big. This is the transformation we're doing. So basically we're just taking, for our new graph, we're taking every single point, and for every single x, we're just doing x minus 5. Every single y, we're just doing y plus 4. So we can literally just write the ordered pairs. So x minus 5 is 1 minus 5. 1 minus 5 is negative 4. And then 0 plus 4 is 4. So if you go over here, you should go, hey, negative 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4 is the first point. That's just another cool way to do it. If you had 2 minus 5 is negative 3, and 1 plus 4 is 5. So that should be your next point. Negative 3 up 1, 2, 3, 4, 5. So isn't that cool? That's another way you can do it without having to like graph this green guy. Which the green guy is not bad to graph, but hey, it's just another easier way to do it. All right, I don't know if you can hear my puppies wrestling in the background. They're super cute. I wish I could show them to you. All right, Grace, have a great day.